Hey everyone, and welcome to this explainer. Today, we are diving into a massive, seismic shift that's currently transforming the entire technology landscape. We are officially moving away from those basic prompt-based chatbots we've all gotten used to, and we're stepping into the era of autonomous, goal-oriented AI systems. It is an incredibly exciting time, and honestly, understanding this shift is absolutely crucial for anyone keeping tabs on the future of software. So, let's just get right into it. Think about this for a second. By 2027, Gartner projects that 65% of enterprises will have deployed some form of agentic AI. 65%! If you're building software today, your timeline to adapt is shrinking fast. We aren't just talking about a minor software update here. This represents a massive, fundamental leap in enterprise tech. It's the jump from an AI that just, drafts a quick email for you to an AI that can independently execute complex, multi-step workflows all on its own. To really wrap our heads around this shift, we need to compare the AI of today with the AI of tomorrow. Generative AI basically needs you, the human, in the loop for every single step. You prompt it, it responds. It's a straight, linear line. But agentic AI? That is entirely goal-centric. It uses these iterative loops to plan, act, and observe over time. It's stateful, it's persistent, and it's designed to be deeply integrated into complex enterprise systems. So here is our roadmap for today. We'll start by defining what lies beyond chatbots, unpack the anatomy of an autonomous agent, diagnose the big brittleness problem, look at the structured cognitive loop and soft symbolic control, and then wrap up with enterprise readiness. Okay, part 1, Beyond Chatbots, diving into agentic AI. We really need to upgrade our mental models of what an AI actually is. The absolute game changer here is that agentic AI is defined by a continuous feedback loop. It's taking a large language model and transforming it from a simple text generator into the literal cognitive brain of an autonomous agent. It can perceive its environment, reason about what it needs to do next, plan out those steps, and then actually execute them to hit a specific, concrete goal. Moving on to Section 2, the anatomy of an autonomous agent. Autonomy sounds amazing in theory, right? But how does it actually work under the hood? What makes up the anatomy of one of these digital organisms? Well, the most basic engine driving this is known as the react loop. That stands for reason, act, and observe. The agent reasons about a goal to generate a plan. Then it takes an action, usually by calling an external tool or an API. And finally, it observes the result of that action. So if a database spits back an error, the agent observes that, corrects its own SQL code, and tries again. It's a constant self-correcting loop. If we zoom in a bit further, researchers have broken this down into 5 system-theoretic subsystems. It is honestly a lot like a human body. The reasoning and world model is the brain. Perception and action execution act as the eyes and hands. Inter-agent communication is how it socializes with other software, and wrapped around all of that is the learning and adaptation layer. It's just a beautifully structured way to think about digital cognition. All right, Section 3, the brittleness problem. Now, here is where reality hits hard. Transitioning from a neat conceptual loop to a reliable, production-ready enterprise system is incredibly difficult. It exposes some massive technical hurdles. AI pioneer Yann LeCun put it bluntly. He warned that without the proper architecture, agents can easily act deluded, stupid, ineffective, or evil when they face dynamic environments. When you take a probabilistic model and give it the keys to execute actions in the real world, well, things can go sideways really quickly. And we are seeing this brittleness constantly in early implementations. Because LLMs are probabilistic, small, tiny errors start to compound. An agent might get stuck in a total infinite loop or just completely forget what its original goal was halfway through a job. But the security risks, those are the scariest. Imagine a simple prompt injection hidden inside an email that tricks your autonomous agent into securely emailing your password file directly to a malicious attacker. That is a massive, real-world vulnerability. Which brings us to Section 4, the structured cognitive loop. To fix this architectural brittleness, engineers had a major realization. We absolutely must untangle the reasoning from the execution. You just cannot let the model think and act in one messy, unconstrained step. And that is where the structured cognitive loop, or SCL, comes into play. SCL explicitly separates the agent's cognition into highly specific phases. By throwing up strict boundaries between thinking, validating, and doing, we can stop that dangerous state drift and enforce strict security checks before any external code ever runs. The SCL framework breaks down into the RCCM loop, That stands for retrieval, cognition, control, action, and memory. The agent retrieves facts and uses its LLM for cognition, sure, but then, and this is key, it hits the control phase. Think of this control phase like a super strict security checkpoint at an airport. Nothing gets past it into the real world without authorization. Every decision must be verifiable. Only then does it move to action, and the whole process is saved perfectly into a persistent memory state.
Next up, Section 5, Soft Symbolic Control.
So what is the secret engineering sauce holding that entire RCCam loop together? It's a concept called soft symbolic control. Basically, it acts as a meta-prompt governance layer. Look, we all know LLMs love to guess, and sometimes hallucinate. That's just probabilistic inference. Soft symbolic control actively intercepts those probabilistic thoughts and validates them against hard, symbolic rules before allowing a single action to happen. It's exactly like having a very meticulous manager reviewing the work of a brilliant but maybe slightly erratic creative employee. And this concept brilliantly bridges a huge historical gap in AI. Back in the 1990s, we had these things called expert systems. They were perfectly controllable, totally deterministic, but they were incredibly rigid. If they hit a rule they didn't know, they'd just crash. Soft symbolic control brings back that much-needed control and explainability from the 90s, but applies it to today's highly adaptable neural reasoning models. It's the best of both worlds, structured governance mixed with graceful, intelligent recovery. Finally, Section 6, Enterprise Readiness by 2027. So how do we actually get these systems safely deployed in major enterprises by 2027? Well, organizations have to build incredibly robust infrastructure around these agents. We're talking about enforcing deterministic JSON outputs so the agent's code won't just fail to compile. We need secure execution sandboxes like E2B or Docker to completely isolate the agent so it can't break the host network. And crucially, we need deep observability tools like Langsmith or Arise Phoenix to trace the agent's complex thought processes so we can debug them when things inevitably go wrong.
Now, if you're a developer watching this, the good news is you absolutely don't have to build all this from scratch. You should be looking into specialized multi-agent orchestration frameworks. There's LangGraph, which is basically dominating complex workflows that require strict statefulness. There's Crew AI, which is fantastic for role-based processes like market research. We've got AutoGen for collaborative coding, and even Semantic Kernel if you need to integrate agents straight into traditional C# and Java enterprise apps. As we wrap up this explainer, I want to leave you with a thought. We are rapidly moving into a brand new paradigm where software doesn't just execute predefined commands anymore, it makes independent decisions based on its own reasoning. And that forces us to ask a really profound question about human accountability. In a world where code doesn't just run but actually decides, who is really in control? It is a fascinating and maybe slightly terrifying challenge to ponder as we build this next generation of AI. Thanks for hanging out with me today, and keep exploring.